Hello everyone, I'm Christina and welcome to this A-Level Mathematics Calculus Series video 18. We're looking at stationary and turning points and this is part 2. So the objectives for this video are to determine the nature of stationary points of a curve f of x using the first derivative. If we think back to the previous videos, we know that the first derivative represents the slope of a curve f of x. So I've sketched a curve f of x here, and I've also labeled the two stationary points. So the stationary points are where the gradient is 0, so that's here and here. And we want to determine the nature of these stationary points. So sketching it out, we can see very clearly that this is a maximum point and we call it the local maximum. And this stationary point down here is a minimum point and we call it the local minimum. How would we be able to determine that just from using our first derivative, f dash of x? So if we have a look slightly to the left of our maximum point, we can see that the slope represented by f dash of x is greater than 0. So it's positive. We have a positive slope here. And then at the maximum point, we have a gradient of 0. So the slope is 0. And then just after, we can see that the slope is negative. So f dash of x is less than 0. And so that justifies that this is a local maximum. If we do the same for the local minimum, we can see just before our minimum point, the slope of the curve is negative. So f dash of x is less than 0 just before. And then just after it reaches a slope of 0 at the minimum point, we can see that f dash of x is increasing again. So it's actually going to be positive. Okay. And just to note, the local maximum and local minimum are both turning points. So if we standardize this procedure to find stationary points, we first want to differentiate the function and solve for dy over dx equals 0 or f dash of x equals 0 to find the stationary points. You can look back to previous videos to see exactly how we do that. We first find the x coordinates from solving this equation, and then we substitute those x values into our function to get the corresponding y values. The second step is to test values of dy over dx to the left. So that should be to the left and to the right of each point. So as we saw before, we were checking the slope of the curve just before and just after both stationary points. We want to look for a sign change of these values. So that means if it goes from positive to negative, that is a local maximum. And if it goes from negative to positive, that is a local minimum, as we saw before. So in the next video, we're also going to look at points of inflection and how the gradient changes around the point of inflection.